All right, Mr. Bucko here with example 1 from 8.3 from Algebra, where we're finding the volume of cylinders and cones. And our first example here is kind of looking at the difference between the volume of a cylinder and a cone. So we have these two figures here, cylinder, cone, and let's say that the diameter and the height of the cylinder and the cone are the same. So that means the circles here are the same, having the same diameter, and the height of each of these are the same. So let's say that these two figures have the same diameter and height. Which of them has the biggest volume, and then more importantly, how much bigger is it? I think that we could probably look at these two figures and determine or take a good guess as to which one of them has the larger volume, how much, which one you can fit more stuff into. Probably be the cylinder, but how much is kind of what we'll get at here with this example. So we'll need the formulas. So there's the formula, or all the formulas for the cylinder, and we're going to focus on the volume formula, which is the volume is equal to the capital B, which is the area of the base, which is pi r squared as indicated here, times the height of the cylinder, which is equal to pi r squared times the height. So that's the volume of a cylinder. The volume of a cone, here's the information from the cone, is equal to the capital B, area of the base, times the height, and then divided by 3, which will give us an insight as to how much bigger one is than the other. But let's use some numbers here and kind of look at these with some concrete examples and determine which one's bigger and by how much. So let's start with the cone, or let's start with actually assigning values for the diameter and the height, because they have the same diameter and height. What are they? Well, they can be whatever we want to, so I'll use some relatively simple numbers to work with here. So let's say the diameter of the cone and the cylinder is 6. So that means the circle all the way across is 6. So let's call it 6. And let's say that the height of these two is 10. So let's say the height 10 here, also here. So let's find the volumes and find out which one's bigger and by how much. So the volume of a cylinder is going to be pi r squared times the height. So jumping ahead a little bit here, 9 pi comes from pi times the radius squared. If the diameter of the circle is 6, the radius is 3, and 3 squared is 9. So 9 pi is pi r squared. It's the area of this circle. Then I'm going to multiply that by 10 because that's the height of the cylinder. So the volume of the cylinder is going to be 90 times pi, and I'm just going to leave it as 90 times pi. I'm not going to change pi to 3.14. This is an exact value. It's actually the best answer to have, and it doesn't deal with any decimals. So I'm just going to leave it as 90 pi. That's the volume of the cylinder. Now to find the volume of the cone, we're going to use the volume of a cone formula, which is area of the base times the height divided by 3. That's going to be 9 pi times 10, because again, the area of the circle is pi times the radius squared. The radius of this circle is 3, because the diameter is 6, and 3 squared is 9. So that's where that 9 pi comes from. Then we're going to multiply that by 10, because that's the height of the cone. We assign that height as 10. And then divide that by 3. So 9 pi times 10 is 90 pi. So we have 90 pi divided by 3. And 90 pi divided by 3, I can do 90 divided by 3. That is 30. So the volume of the cone is 30 pi. The volume of the cylinder is 90 pi, which leaves us with the fact that the cylinder is 3 times the size of the cone, because 90 pi is 3 times bigger than 30 pi. And we can see that in the formula. The formula for a cone is exactly the formula for a cylinder, just divided by 3. So in all cases, if a cylinder and a cone have the exact same dimensions in terms of their diameter and their height, then the cylinder will be 3 times the size of the cone.